So this is a common question. I think this question came out like in one of the 2000s paper also. So this is not the only one with this kind of question. I think the part 4 one, which is using the value of x1, right? So the thing is, if you want to sketch, just take your GC, then you go to this one, just key in remember how to key in the domain, -3 to 3. So you put like alpha e x, okay? Then this case here with sin x, right? Okay. Put divide, then bracket. Inside here is a domain. So you want it to be -3 to 3. So here will be -3. This test here, the most detestable word on your GC. Okay. Nobody like. Okay. Go to conditions. Then you put in between 3. This is important. You need to put this down. Then once you're done already, you can just zoom standard or you can just adjust. So usually what I'll suggest is don't so x min are -4 and 4. There are a lot of wasted white space around. So I'm gonna just put -2 here. Yep, here like that. You check you just trace -3. This one is not 0. Trace, put 3. This is also not 0 here. So there's a sort of like a horizontal asymptote. So you just draw it like that. Then I didn't ask us to do like the max min point, so it's fine. I think the end points you just label. So this one will be trace -3, -3, comma 0.007 here. Then for the other side, 3 and 2.83. Part 2 is just expansion. Yeah, it's standard series. So part 2, just a few steps. So take out what you need. Fx is equals to ex sin x. You need all the way x cubed. So go from m26. So this you need all the way to x, including the term x cubed. Oh. 3 factorial. So this case here. Half x squared plus 1 over 6 x cubed. X minus 1 over 6 x cubed. So for this expansion, I would suggest just align them. So this will be x plus x squared plus, oh, the last one don't need. Then minus 1 over 6 x cubed. Like that. A third. Is the answer correct? So we were told on the same diagram, draw both graphs. Did you know the answer in part 2 by GX? So part 3, actually part 4 is an interesting one. Part 3 is let GX equals to x plus x squared plus 1/3 x cubed, right? So draw on the same diagram, go to your calculator. X plus x squared plus x cubed over 3. Okay, if you look, if you check your calculator, right, your Maclaurin curve touches the original curve like that around here. Okay, so very likely it's correct. Okay, so it's one way to safeguard. So we are told to label the two clearly. So you label this as y equals fx. This one label as y equals gx. I want to do part 4. Part 4, set of value of x for which gx is within plus minus of the value of fx. Okay, meaning to say you want to find a deviation, right, where this guy here is 0.5. Okay, it can be 0.5 or minus 0.5 if you are, it depends on which curve you are referring to. Okay, so the deviation, you see here is like they are superimposed in between, right? So if you look at the graph properly, right, in between here, not an issue. We know that the estimate is clear. The estimate is actually very accurate because it's close to 0. But as it starts to deviate, I want to find the gap which is 0.5. So that's the whole idea there, okay? So, how to find? Part 4, you just find, is it okay I put gx minus fx? I want it to be within 0.5. Within, you can put equals to or not equals to. I think it's really depends on interpretation. So within is like that, right? But is this correct? If gx minus fx is less than 0.5, you only consider plus 0.5, right? Because you take the purple minus of the blue. Don't forget that you can also have minus 0.5 here, okay? So actually, if you want within 0.5, you have to know that you need to put the modular sign. Because you can have gx bigger than fx. The reverse is also true. You can have fx bigger than gx. So essentially, this will be negative 0.5 gx fx 0.5. Is this okay? So what we'll do here is we actually is just putting in the values in. So it's x. This is gx. So I'm put this as x plus x squared plus 1/3 x cubed minus of ex sine x. I just solve this inequality. Use GC and solve this. What you do is you just you want between 0.5 and minus 0.5. Okay, what is the easiest way to do? You just plot this graph, guys. You just plot this graph. There's a y, one big y here. Then you just find between 0.5 and negative 0.5. So essentially what I'm going to do, I'm going to key this in the calculator. So here. Oh, you can just y1 minus y2. Yes, you can do that. Correct. But I'm just going to key in just x plus x squared plus x cubed over 3 minus ex sine x. Okay, so this is what we want. Then what we do is we need it to be negative 0.5 between these two, sandwich between these two horizontal line. Graph it, but of course, can you just zoom to the part where you need the solution should be around here. Click here. And then you just find the intersect between the lines. One is this one. So this is within. Anything that is within is here to here, right? Do you need to draw it? You can just write from GC, yeah, but draw it out to help you understand. So from GC, 1.96, 1.56. Okay, within 0.5 plus minus.